Here we are looking at example 4G from our 1.3 number 2 set of notes. We're asked the limit as x approaches 0 of the tangent of 3x over 2x. Now, this is kind of similar to our example that we saw with 4E. However, these guys don't actually end up matching. So again, we're not really 100% sure if it's in fact going to come out to be like that limit of 1, especially again because they're not matching. Now, one thing though that we can do is use some of those techniques that we kind of used with that 4E. So let's go ahead and break up this tangent function into that sine and cosine that we've seen. So when we do that, we have the limit as x approaches 0 of the sine of 3x all over the cosine of 3x all over 2x. And ultimately that 2x is also the same thing as saying 2x over 1. Now what we have here is really a fraction divided by another fraction. So we can actually go ahead and rewrite this such then that we have the limit as x approaches 0 of the sine of 3x all over the cosine of 3x divided by 2x all over 1. Well, again, anytime you're dividing by a fraction, really you're multiplying by this reciprocal, the second fraction. So let's go ahead and change what that looks like. So then we have the limit as x approaches 0 of the sine of 3x all over the cosine of 3x times 1 over 2x. Now, when we were looking at example 4E, what we did is we swapped this 1 and the sine on top. Now, that's not going to be such an issue with the cosine part, but even if we swap these guys, in fact, you know what, let's just go ahead and just show it. So we have the limit as x approaches 0 of 1 over the cosine of 3x times the sine of 3x still over 2x. So right there, again, we've just, since multiplication is commutative, we just swapped those two. Now the issue here is we still don't have something in common between these two numbers. So what we're going to do is we still have the limit as x approaches 0 of 1 all over cosine of 3x. So that guy's remaining unchanged. But what we can do is ultimately we really have a 1 on top. And if I was to multiply this 2x by 1 on the bottom, we're not really changing this. So again, we're pretty much just multiplying it by 1 over 1 here. And the reason why we would do that is I can go ahead and break up this sine of 3x over this 1 times, I'm also going to borrow this x part. And the reason why we would just borrow the 1 and the x is because it's getting now really close to that idea with our definition that we've seen. And then we also have this times, well, there's nothing really on top except for this 1. And on the bottom, we only have really just this 2 that's left over. The 1 and the x actually already came with them during the middle one. So ultimately, we just have 2 on the rightmost fraction. Now we can go ahead and apply our limit to all 3 of these. So once we do that, we have the limit as x approaches 0 of 1 over the cosine of 3x times the limit as x approaches 0 of the sine of 3x all over x times the limit as x approaches 0 of 1 over 2. Now, when we're just looking at this, we see that we have this function, the sine of 3x over x. Well, in order to get it kind of like common with that number that we need to have this 3 on the bottom. So we're going to go ahead and do a little bit of foo by multiplying 3 on the bottom, but 3 on top as well. For this one, on the right side, it's just a constant. The limit as x approaches a number of just some constant. So it in fact just comes out to be that constant. You maybe remember that from class or the notes. So this rightmost one, this limit is not that bad. This guy over here, again, just like when we saw with example 4e, he is very attainable as well. This will just come out to be 1 on the leftmost limit. So the only really hard one that was kind of giving an issue for us was actually the breakup and then what you'd have to multiply to get that definition that we can use. So again, now if we go ahead and use direct evaluation, we end up with the limit as x approaches 0. Well, we'd end up with 1 on top for this leftmost guy. The cosine of 0, again, is just 1 when you go ahead and plug that in. Times, I'm going to go ahead and take this, or I'm going to go ahead and rewrite this middle one. So we have the limit as x approaches 0 of 3 times the sine of 3x all over 3x times, again, this limit is nice and easy. It just comes out to be a half. And if you recall, and by the way, I did that just so we don't have to keep rewriting all these limits and things like that. But if you recall, we can go ahead and take out this 3, which is a constant, and throw them in front of our limit. So really we have 1 times 3 times the limit as x approaches 0, the sine of 3x all over 3x times 1/2. Again, this is just a definition that we've seen recently, so that'll just come out to be 1. So really we just have 1 times 3 times 1 times 1/2. So it looks like our final answer just comes out to be 3/2 our limit. So again, that is example 4G from our 1.3 number 2 set of notes.